Today we're going to look at a few videos about modeling using our knowledge on Pythagorean theorem, its triples, and our special right triangles. So in the first example here, it says, let's find the perimeter of a rhombus with diagonals of 24 feet and 32 feet. My suggestion is sketch a picture to help you out. So remember, a rhombus has four sides, but the rhombus does not contain right angles. So it looks like a parallelogram where it's slanted. But remember, when you have a rhombus, different characteristics take place. Because we are given diagonals in this picture, well, I'm going to sketch those in. So there's one diagonal. There's the second diagonal. When we have a rhombus, diagonals are perpendicular. So there I have right angles, which now allows me to see that I really have right triangles in this picture. The other thing I know is that diagonals bisect each other. We know that the diagonals are not congruent because one's 24 and one's 32. So if I break up 24, because that diagonal is being bisected, that gives us 12 and 12. If I break up the diagonal of 32, because it's being bisected, that would be 16 and 16. So now you have all of these right triangles where you have two sides. Your goal is to find the third side, which notice that in every single triangle, it's across from the right angle. We want to find the hypotenuse. So you could use Pythagorean theorem, or you could think about your special right triangles. The fact that 12 and 16 are both multiples of 4, notice that 3 times 4 is 12, 4 times 4 is 16. Hopefully we're starting to recognize this is a 3, 4, 5 family with everything being multiplied by 4. So since it was the hypotenuse that we wanted to find, 5 times 4 tells us that 20 is this side of the rhombus. But remember, a rhombus has four sides that are congruent. And my problem is asking for us to find perimeter. Well, perimeter means you want to add up all of the sides. So if there are four sides and they're all 20, 20 times 4 is going to get us that perimeter. So that would be 80. Now, because this problem deals with units, I want us to include our units. So the perimeter is really 80 feet. If we take a look at this next example, it says find the legs of the isosceles triangle whose base, I'm sorry, not triangle, trapezoid, whose bases are 12 and 18 and whose height is 4. Remember, a trapezoid has four sides. We know that if it's an isosceles trapezoid, that you are going to have two sides that are congruent. Your bases, remember, are the two sides that are parallel, meaning that they won't intersect. So since I drew a smaller base on the top, that has to be 12, which means that 18 is the bottom base. I know that these two legs are congruent because of that word isosceles. And now if I'm given a height, I know that the best way to do this is to go from one corner and basically draw that altitude that represents a height. Now, drawing it once isn't really going to benefit us. That's why I drew it twice. Notice that by drawing that height twice, we have now created two right triangles and a rectangle in the middle. So if we think back to our properties of a rectangle, opposite sides are congruent. So if it's 12 up here, it's 12 there. If the whole entire bottom side is 18, hopefully it makes sense that I'm going to be subtracting those two bases. I find out that what I have left over, this piece right here and this piece right here, have to add up to 6. Now they're going to be congruent. So I'm going to cut that in half. And that tells me that this side is 3 and so is this. And now if we take a look at the fact that I want to find this leg, well, in this right triangle, I now have 2 out of the 3 sides. And then right off the bat, we notice that it's a triple. It's our 3, 4, 5 family. We didn't have to do any type of multiplying or dividing to get that. So we know that our side is 5. Because this problem didn't have anything with units, I don't have to worry about writing units. 5 is our answer. In the next problem, it says find the perimeter of an equilateral triangle with a height of 30 yards. So if I want to sketch an equilateral triangle, we have to remember that an equilateral triangle means that all of the sides are equal. So this side, and this side are all congruent. We don't know what those sides are because we're trying to find the perimeter of it. But we know that the height is 30 degrees. So I'm going to drop an altitude, which creates right angles. And so I know that that is a length of 30. Right now, my picture doesn't give me enough information because I only have one side. But by drawing that altitude, it actually bisects that side here. So I know that those two little pieces are congruent. I still don't know what those little pieces are though. So that still isn't quite going to help us. The fact that equilateral means all the sides are congruent also means all the angles are congruent. Remember, 3 angles of a triangle add up to 180. Divide 180 by 3, and that tells us that this is 60, this is 60, and technically that angle up here is 60. With the altitude being drawn, now hopefully we see that we really have 30, 60, 90 triangles. And so the side that was given is 30. Notice that it is across from the 60 degrees. And if we remember our practice from yesterday, x times the square root of 3 is what always is represented the side across from 60. And so in this case, x root 3 has to equal 30. So to solve for x, because remember, x is always the side that is across from the 30-degree angle, I am going to get x by itself by dividing by the square root of 3. I'm going to have to rationalize because I do not want a square root in my denominator. So I'm going to multiply the top and the bottom by the square root of 3. When you multiply straight across, that would be 30 root 3 on the top. Square root of 3 times the square root of 3 is 3. And 30 divided by 3 tells us that that would be 10 root 3. So now that's just this little piece right here. Okay, that is not the whole side to help us find the perimeter. But like I said, that side is being bisected. So if that's 10 root 3, so is this. So put those two together, and that means that each side is 20 root 3. And so because we want the perimeter and there are 3 congruent sides, I'm going to multiply 20 root 3 by 3. And so 60 root 3. And notice that we have units. So 60 root 3 yards would be the perimeter of this equilateral triangle. The last problem I'm going to look at here is this problem where I have two 45, 45, 90 triangles connected together. My goal is to solve for x. Notice that the only value that I have is down here, so we're going to have to start with the bottom triangle. Remember, the sides of a 45, 45, 90 triangle are congruent, but what I really need is the hypotenuse in that bottom triangle because then that side is connected to the triangle of the side that I really want to find. Because we are given the side that is across from the 45, which is the smallest side, remember our properties tell us I want to take that smallest side and I need to multiply it by the square root of 2 to get the hypotenuse. So square root of 2 times the square root of 2 is 2. That means that 8 times 2, or 16, is going to be the hypotenuse in that bottom right triangle. Now that is the side or the leg across from the 45 degrees in this upper right triangle. And so because that is the leg of a 45, 45, 90, we take the leg and we multiply by the square root of 2 to get the hypotenuse. Notice that what I want is the hypotenuse in this particular problem. So 16 root 2 would be my answer.